Hello everyone, welcome to the AI India tour. This is Lakshit Pant from Azure Developer Community, and this is our third tour with this AI series, that India tour series that we are doing. And today we have our industry leader, Azure Developer Community leader from Tamil Nadu, Vivek Raja sir. He has been contributing with us since very long, more than 2 years, and he's a VP at Nextem. He has been driving us around Azure machine learning and AI. So today he'll guide you about Azure Machine Learning Studio and how you can upskill with Azure Machine Learning. And from a industry per se, what machine learning and AI discussion are going in and around in the industry and why it's required at present. So there is something that Microsoft we are driving AI Odyssey series. I'll explain it to you later at the end of the session. Till then, I'll quickly pass to the stage to Vivek Raja sir. Over to you.
Thank you, Lakshit, and thanks for this opportunity to talk. And I'm very much excited to interact with you people today. So, this session will be mostly interactive. I want you guys to ask as many questions as possible in the comments. And time to time, I'll be actually throwing a couple of some insights and some questions as well. So, without any further ado, let's get started. So, before we get into this particular session, I would like to remind you that. Or maybe I can ask a question. So, how many of you here are completely new to Microsoft Azure? How many of you are the first time you are trying to experiment with Azure here? You can drop that in the comments wherever you are. Or I will assume that you are in the initial or in the beginner stage, or anyone who's trying to scale their machine learning experience to an industry level. So, whoever here today, you need not worry about your machine learning expertise or anything else. Even if you're completely new to Azure and AI ML, this session will be quite useful for you. And I can assure you that by end of this session, you yourself can be able to go ahead and create your own machine learning models and deploy it on the cloud. So that sounds interesting, right? So today we won't dive much deep into the technical concept of machine learning, but we will talk about how you can take your machine learning workflows and solutions to the cloud. And there is no prerequisites as being said. So with that being said, let me start. So what I do, thanks, Lakshit gave me a quite bit of intro. I'll talk about what I actually do in my startup and community space as well. So right now I'm VP of product at Nextem. Nextem is a brain computer interfacing company. So we are also in Your Story Tech 30 startup winner. I'm also an AWS machine learning hero. I'm a very fond of machine learning, so I talk about machine learning in various providers and platforms. And I'm also a recipient of Invent and Simplify Award, and I've been running Azure Developer Community since its inception. So I very well remember when this particular initiative was launched, and I was handling a couple of cities in Tamil Nadu, and we organizers, Navneet Gopal and everyone has come together to host consistent events in Chennai and Tamil Nadu community. So you can get in touch with us to participate in in-person events, and we are planned for a series of virtual events as well. So I also run a couple of other communities such as User Group Madurai, and I'm multi-cloud certified, uh, DP 100, AI 100, and a lot of Azure related certifications, and also a Guinness World Record holder. So besides my startup and my community, I also like to do a lot of research work. So I publish around a couple of research papers, and I also published a couple of two patents. And during my college times, it was my interest to actually participate in a lot of hackathons. And now it has been nearly 6, 7 years which I've been in the hackathon ecosystem. Right now, I'm being doing that for a lot of juries and judges as well. And meanwhile, I started a little bit of content creation with respect to Reels. So I'll give you my links where you can connect with me, LinkedIn and so on. So this is my handle. I am sure if we are able to scan, if at all, or I'll try to unmute. I hope so the QR code is available. If not, I'll just drop my link tree in the comment section. So before that, this is my intro, and let's get started right away. So before we go into this particular session, does anyone have any preliminary questions about what is going to happen in this session or anything that we want to talk about? And just to be said, comment session is not for your chats. Comment session is to ask very valid questions that you want to talk about or ask about your fellow peer as well. So if you're doing any personal chats, you can keep it outside this YouTube comments. But being said, let's get started with the session. And do you have any questions, like any preliminary questions or doubts or misconceptions about what is Azure or what is Azure AI or machine learning do? Okay, what is the outcome of this session? So by end of this session, you will be able to understand what is an ecosystem of Azure machine learning really looks like, and we will also know about how you can create an end-to-end machine learning workflow. So right from uploading or getting a data set to training your machine learning models and deploying it on the cloud for inference, like real-time inference. We will see all that and on the coding level as well as in the console level. We will also see a designer workflow where without coding, where you can actually connect a couple of nodes to create your whole machine learning workflows without any coding language. So that will be the outcomes of today's session. Since it's 2 hours, Azure Machine Learning is a very big service that we can't cover in 2 hours. But I have made sure I have arranged this session in such a way that it covers most of it and helps you to get started immediately. And you will also receive the code snippets and the notebooks which we are going to discuss today. And of course, it will be a hands-on session. This session, there is one more question asking about do these sessions explain about trending Gen AI? Cool. Uh, we will not talk much about Gen AI, but I'll sure introduce you to a couple of how you can get started with Gen AI models. We won't touch base mostly on that today. Um, I've been receiving some error code, which we won't be able to take it up. But anyway, let's get started again. Cool. You can join the Azure developer community. You can go. This is our Tamil Nadu community where we've been running for a couple of things, and it is Samira. This is completely for beginners. So no matter if you are a person who does not know machine learning or does not have any experience in cloud, still you will be able to follow up the session, and by end of the session you can yourself go create your account and start working on it. So that will be one of the major outcomes. So the agenda is going to be very simple. I'm not going to bore you guys with any theoretical concepts, but there will be few concepts which you need to know before we get started. And after that, we'll be completely playing around with Azure Machine Learning Workspace in Azure Cloud, and we will run a couple of code snippets as well. Cool. So the agenda is like first we will get to know what is Azure Machine Learning looks like. Okay. So that is where a little bit of theoretical concepts will be there, which is very, very, very must to get to understand how it works. Then we will see how to train your models, which is quite interesting. So a lot of people here might have worked a little bit on Jupyter notebooks, and you might have gone to your notebooks and run models, but have you ever run that on cloud and how does it look like? What are the formalities and what is the configuration that you have to do? So we'll all discuss that. And finally, with this most interesting part, that a lot of people today or people who are getting started do not take their model to deployment, which I mean that you train your model and the model just sits in your notebook forever. Today, we will also see how you can actually host your machine learning model, and that is very fairly simple. So, once you host your model, you can just use API request to get inference out of that, which you can integrate with your existing application as well. So, a little bit of prerequisites is that I hope so you guys have very basic understanding about Python language because we are going to deal with a little bit around Python. And basic understanding of machine learning, this is very, very minimal. You don't need to know very much in detail, but a little bit of knowledge might help. Totally optional. And third one is an Azure account because that is very much necessary. So if you're going to do a hands-on with that, you definitely need an Azure account. There is a free tier available, but please be aware of the cost which will incur during this workshop. What I'm currently doing, the account and the stuff is running in my own bill. It does make some bill as well. So today, before we go into all these stuff, just make sure that you are aware of the bill and costings so that you don't incur any extra bills. So fairly very simple. We are going to start with what is Azure Machine Learning looks like. So first, we need to understand what is the actual workflow that we take when we do a machine learning project or a solution or even an industry use case. And what are the issues that happen when we actually implement ML? And we are going to also see a couple of architecture and stuff during in terms. Could you help us create? Okay, it's very simple, Ram Kumar. If you wanted to create an Azure account, just go to portal.azure.com, do the sign up process. That is it. You don't need to do anything fancy. Okay, I'm running a couple of technical issues here. My second monitor is okay. Now it works. It's very fairly simple. You just have to go to portal.azure.com and create an account. It will follow you with a couple of instructions and just follow it. So first to get started is about what is machine learning workflows. When we actually take up a machine learning project, besides the solution that you are going to finalize, that is the algorithm, getting the maximum accuracy, that's all there. But that is just one part of your machine learning solution. The whole solution lies in how you're going to implement it step by step so that you can scale your machine learning projects from just projects to solutions. So there are a couple of workflows that you have to do. Even I guess you might have followed the same workflows in your notebook. First is to understand where is your data source is. It might be a local files, it might be at Kaggle, it might be in an open source data set, somewhere where you can access a data set for free. Or there are few chances where these data sources are not just available as CSV files that we usually do, but it might be available as graphs, it might be available as databases, it might be available as CSV files. So, as a machine learning engineer or a person who wants to solve a machine learning solution, it's your responsibility to first consolidate all the data sources and make it as one format. One preferred format for is to easy to work upon is making that as a CSV file. So today's scope will be only limited to a local file, uh, not more than that. The second thing is about creating a training environment. So let's take a step back. Let's assume that you have a Python script or a Jupyter notebook running in your system. What is your training environment? Your training environment is nothing but your own system configurations, which is, for example, my system is running a Mac M1 and it has 8 GB RAM and 128 GB or 256 or 512 or 1 TB hard storage and so on. So this is your training environment. Will this be sufficient to run machine learning models and train machine learning models? Depends on the use case. Depends on which you are going to do. So now let's actually, we need to create a training environment that can be portable, that can be shifted from one compute solution to another. So that also depends. The third one is about selecting your machine learning model. So once you have a data set, once you understand what type of machine learning problem that you're dealing with, can anyone in the comments know what is different types of machine learning problems that exist? One simple hint that I can give is, yep, there is supervised. Can you name other types of machine learning uh, problems that you know? Okay. One is supervised, one is unsupervised, and the rest is reinforcement learning. When it comes to supervised learning, we have a lot of problems with that. So a lot of subtasks, so machine learning problems such as regression, classification, and so on. So, can you name some couple of algorithms that you are very much familiar with? For example, it can be logistic regression, SVM, etc. Any machine learning model that you know. You can drop that in the comment as well. So based on your comments is where how the structure of this whole session will be. We'll make sure that it accommodates your expertise level. Cool. So we have SVM, we have logistic regression, we have random forest, so many things. So once you have your machine learning model and once you have your data, we need to write a training script that connects the data set with your model, and we need to train it. And where does the training take place? It takes place in your training environment. So now you can connect the dots here. The reason why we are taking it slow from here is that these workflows are exactly what we're going to implement in cloud. So once we are familiarizing with the training script, we have your training script, you have your data. The training script can take data and run it. It will run on the training environment. So the next step is training the model, which is nothing but executing the training script. So once that is done, the outcome of this particular step will be you will be able to get a couple of metrics, which is like your the accuracy of your machine learning model or your F1 score of it. So we will be able to get that resources or that metrics, which will help us decide whether we wanted to improve that machine learning model or we have to leave it as such, or maybe go for the next step of deploying it. So if you are not satisfied with uh, this one, your accuracy is when you go for hyperparameter tuning. Hyperparameter tuning means you take a machine learning model algorithm. For example, Ram Kumar said SVM is one model. So SVM has a couple of parameters. It has alpha as one of the parameters. Like you go and fine tune the value of alpha, and you see whether it improves your machine learning model. You have to again redo the steps of training the machine learning model until you are satisfied with the machine learning model outcome. Once you are done it, you can train on multiple models and see which gives you best result. And then you choose your best hyperparameter tuned model as well. Once you're satisfied it, you finalize the model, and now you have to create something called a deployment environment. So let me give a very, very, very simple example that everyone can relate here. How many of you here use ChatGPT on daily basis? I'm sure pretty much most of you do that to complete your college assignments or to write a LinkedIn post or much more than that. How many of you use ChatGPT here? Have or know about ChatGPT here? Cool. There are a couple of people who have been using it, right? So have you ever thought about when you go to chat.openai website and you type a particular string that brainstorm me about 10 different dog names. Did you ever think about what happens when you click enter? This particular string input goes to a machine learning model, and the machine learning model creates the output. Here, the output is text, creates the output, and it again sends back the response to where the request was actually generated, and it displays in your uh, system or in your browser, in your tab. But imagine like there are around millions of people right now using ChatGPT. How do you know that when you correctly send your response, the response is very, very quick? How do you manage that you can handle a million users on the fly? Mouse events get trigger algorithm. I'm not sure how that works, but anyways, when you click enter, your request goes to a machine learning model to predict something, right? So if millions of people are accessing a particular model, how do you ensure that the machine learning model is available to handle this much of traffic, this much of request input traffic? This is where your deployment environment plays a vital role. It's about creating the right compute, that how much server power that it can handle, and what sort of input that it can take. Yeah, pretty much. Yeah. Uh, we got a little bit of correct answer called virtual machines. Good, we are going the right path. This is where we will today see, even if your today's model is going to be accessed by one people or even 100 or even a million, today's session It's all going to take you 10 minutes to create that sort of a scalable environment. Sounds cool, right? That is what we are going to do. And the best part is you don't really need to know about what is machine learning or how things work behind. So I have made it very simple that you can execute commands and code to make it very easy. But it is very necessary for us to learn a little bit of theory beside it. So I will actually, this section, the first section is going to be a little bit of talking. Then we will completely do the coding part. As I said, this is very much necessity for us to understand how things work later. So next comes the inference script. Inference scripts are where when you send a particular request, it takes and sends an input to your machine learning model and gets an output, and then it communicates back to your HTTP response. So the inference scripts takes care of it, and performing prediction is where your model actually does the prediction. Yeah. I've been getting quite a number of good answers. Good that you're all active. Unsupervised is, yeah, one such type of machine learning problem. Random forest is one algorithm. Good. Keep the answers coming because I'm going to keep on asking you a lot of questions for which you already know the answer. Okay. So have you thought about, okay, we know that these are the stuff like you may now ask me, okay, Vivek, this is something I'm a machine learning person. I have done some machine learning projects in my college or in my work. This is something I do daily. What are you actually trying to say? What is something that you're going to teach me new today? This is what actually makes a differentiation between a project and a scalable solution is that how do you maintain different type of resources? So every time you train, how do you maintain the versions of it? And how do you provision virtual machines? Like Palasala actually mentioned that you use virtual machines for your training and deployment. How do you ensure that you spin up virtual machine on demand? And how do you ensure that your model is installed there to accept requests? And how do you reuse your machine learning workflows? Like, for example, if I create a workflow that data cleaning, model training, can I reuse the same steps for my future algorithms or workflows? It is possible. And once you deployed, how do you ensure that your deployed model is able to handle this much of traffic? Again, the same question. So we know ChatGPT is able to handle that much of this one. How do, as you are a data scientist, you are a machine learning engineer, how do you ensure that this is maintained? So this is what we're going to see, and you're going to see how this actually is solved from Azure ML. There are a lot of ways to perform machine learning in Azure. One is the portal where you go to a machine learning studio and you do a little bit of UI, you add a little bit of code and you do it and you can create models and you can deploy it. One is a designer. We'll also see about designer. Designer is where you don't even know about any coding. You just have to do drag and drop and finish with this one, your complete coding. And the second thing is CLI. You know what is a CLI? Are anyone familiar with what is CLI? Can you know the expansion of it? If you know, please drop it in the comment box. And the third one is, as I said, one of the prerequisites for today's workshop or this session is that uh, a Python programming language. Even if you're very much basic, a Python programmer who knows how to deal with data frames and pandas, you're good to go. So we will use Azure Machine Learning. We can use Visual Studio Code and some couple of IDEs. Okay, we got a couple of answers. It's not command, yeah, it is command line interface. Command line interfaces are quite tough, uh, Linux commands, it's cat, you can use ls and so on so. But when you use CLIs of this complex, it's like you need to use commands properly along with the parameters and everything. That is quite tedious, so let's not do it today. Okay? We will see how you can use Python SDK and you can easily do that. So this is very basics for people who are very new to Azure Machine Learning. As Ram Kumar said, how to create your account. Once you created your account, this is what you actually need to know how Azure really looks like. So we have something called management groups and we have something called subscriptions. Subscription is where you get billed according to it. So I have created a paid pay-as-you-go subscription. You can have multiple subscription in one organization as well. And based on that resources that you create within that subscription, you're going to bill for it. Okay. And you can you can actually group resources in logical terms called resource groups. So it is nothing that, for example, if I'm going to do machine learning. It's not about creating a machine learning workspace, but also I need to create a couple of storage accounts, Azure application insights, or maybe separate other stuff, right? These can be grouped under a single term called ML so that I can organize them very well. It does not actually contribute to anything especially, but it helps us to organize resources in a very long run. When it comes to Azure machine learning, these are something that is already there. One is the main workspace is backed by something called storage accounts, like wherever whatever data you do deal with or whatever files it generates, it all goes stores there. Container registry is where did we talk about something called environment, training environment, right? What is training environment? Is that or a deployment environment is where you define what is your configuration that you need to install in your instance to run. So to install that instances on the fly, we use something called Docker. To store that Docker images or stuff, we use container registry. Very simple. If you're not familiar with Docker, just ignore that and you say that just installing a particular OS in an instance. Very simple, but not exact right terms, but something very simple. Key vault is where for authentication and to maintain the secret keys and everything. And application insights gives you an insight about how the whole workflow works and or insights about logs and everything. So coming to the Azure Machine Learning Workspace, it has compute instances, compute clusters. Instances are nothing but virtual machines. So what we actually spoke about. And when it comes to workspace, we have a couple of things. One is environment. We know what is an environment, which is where it defines the configuration of your virtual machine or where your scripts or something is going to run. Experiments. We'll talk about what is experiments. And we'll talk one by one what is pipelines, datasets, model, endpoints as it go. But I guess it's pretty much evidently visible from what we are looking over here. So workspace. So workspace is nothing but it is a group of resources that comes along with it. And it is nothing but how you use resource groups as a way to logically contain everything within one particular name or tag. It's similarly how workspace works. So you keep all your work and your models, data sets into one single workspace for an organized way of doing it. Experiment. Okay. This is quite an interesting experiment. So before we go into what is experiments, I know I'm a little bit making you guys bored about talking a lot of stuff, but trust me that once we switch on to Azure Machine Learning Portal, once you see all the stuff over there, it'll be very easy for me to not explain it and easy for you to even pick it up. So let's deal a little bit about your technical stuff right now. Okay. So experiments. So on a basic term, you know what is an experiment? That you do something and you see the results of it, and you might reiterate with different configurations to see which part of your experiment actually succeeded. So let's take a scientist or someone. So or maybe yourself who is in the plan of finding the next cure for cancer. Right? You do something and you note down a result and you create a template of it that okay, I need to first do this step 2, step 3 and everything. You follow all those steps and you note down the result. It doesn't work. You change your steps, you reconfigure it, or add more parameters, change your parameters, do all the stuff, and you get the next result. You keep on doing it, and logically, every single run of the template is called jobs, and the template is called pipeline, and the experiment is a collection of pipelines, and so on. So it's logically you can actually put it under it. So every single run is called a run context. We will talk a little bit about that when we write the code. Nothing much to worry about right now. So I think that explains most of the technical concepts that we are dealing with it right now. So, what I'm going to do is I'm going to right now start with your uh, coding or your demo sessions. So, let me first spin up my, okay, just give me 1 second so that I can bring up my screen. Cool. I guess you guys can now able to see my screen. Yes. So I'm going to zoom this. So once you create an account, it looks something like this. And it's about these are the Azure services or something that you recently used. And we know what is a subscription and we know what is a resource group. It's logically it's contained. Let's see what is there because I've already created a couple of resource groups for us for easy demo. So it's located in some location, East US2. Cool. So shall we get started with machine learning right away? So all you have to do is first go to a service called Azure Machine Learning. You can create a workspace. You know what is a workspace, right? Workspace is the collection of all experiments, jobs, pipelines, and everything. You can create a new workspace. It asks you a couple of details such as name, resource group, and everything. And you guys know what is a resource group. It is now to logically put my machine learning services under one resource group for some uh, logical consideration. Name, storage accounts, and everything. If not, it itself will create new for you, or you can attach your existing storage accounts as well. Once you enter all the details and you click review and create, it will create a new uh, this one. So I'm going to go with an existing this one. So okay, so your resource group and your subscription looks something like this, and you can just enter it. Wait, let me zoom it out. So you have an option called something called Launch Studio. You click on it, and that takes you to your machine learning workspace. So here we have a couple of things to do. One is home. One is called model catalog, where you have all generative AI this one. So another one is called notebooks. Notebooks is where the same thing which you have created from your local is same over here. You can create your notebooks. We will talk something about automated machine learning as well. And a designer is where you can create a machine learning workflows without any code, which we will do today as well. We will skip prompt flow for today. There is we don't have Gen AI for today's scope. And we have some assets called data, jobs, components. So you know what is the data? You go and create your data set over here. You upload your file or you connect your existing online stuff as well. And second one is called jobs. Whenever you run something, a pipeline or something, it accounts as a job. We'll talk about it. Components for now, if you're a beginner, you can safely ignore. Pipelines. We are going to create some pipeline and see what it looks like. And you guys very well know what is an environment. It is a web page. So all you have to do is go to portal.azure.com and then you sign up. Okay, so it is a web page here, and you just create an account. And we have models, we have endpoints, and we have something called compute. So as you know that we have to run your machine learning workflow somewhere. So we need to have a compute, and we saw there are two types of compute, which is one is instances, one is cluster. I've already created one instance which is of one type, and it already costs something. It's of this virtual machine of this size. So we will ignore the other stuff for now, and this is going to be our basic concepts. So shall we go with? something very easy first that you don't have to use any coding. Can we go with the designer so that uh, Kubernetes, yeah, you can create Kubernetes clusters as well. Yes. First, we will show you something called a designer. A designer is where you can create your whole machine learning workflows without any coding. So let's get started. So I'm going to create a pipeline. First, let me create a very basic pipeline, and then I can show you some examples which is already available. So before we get started with machine learning, what is something which is very important for us? We need to import the data. So there are some existing sample data, or you can bring your own data from here as well. So these data sets are available from uploading it to the data sets. So first, let's create a data set and see how it looks like. So first, I'm going to click create sample data set bootcamp, any common name, and then you click next. Now you can select the source where you're going to import your data set. So you can import it from Azure Storage, or you can upload it from your local system, or you can actually connect it to your SQL dataset and or web files. So if it is a publicly available URL, you can do it. Or Azure itself provides you a lot of open source datasets that you can immediately get started with. So for now, I'm just going to skip this step because we already have it. So once you create a dataset, it looks something like this. Okay. So let's go ahead and now create a designer. I'm going to use an existing sample dataset for now. So this is a dataset of census income, and it's going to be a binary classification. So which means you guys know what is a classification problem is. If not, you can safely ignore it. No problem. The next thing what we are going to do is we're going to add some transformations. That is how to uh, manipulate your dataset. Few thing is to clean your dataset. That is something here. So all you have to do is you can just connect your data set to the other pipeline. I mean, like I want the data set to be clean. So I click the data output and I connect it with a pipe. So I can zoom it and show you guys as well. So you just click like this. So now you need to configure what missing data you really need to do about here. So I'm going to double click it and it has a couple of stuff to be done. So what is being here is I need to select the columns which I need to clean. So I'm going to click edit column and it asks me to enter a couple of column names. So it itself has loaded the column. What I'm going to do is I'm going to clean age that if there is any missing values or stuff, I'm going to do it. And let's say I'm going to also clean capital gain and capital loss, or I'm going to make it average if there is a missing value. So what you do is once you can do a custom substitution that if you encounter such and such data, you can replace it with your own value, or you can replace it with a couple of these stuff, or you can remove your entire row if you really want to. So what I'm going to do is I'm going to replace the values with mean, which is very common approach, and that should do. Once I'm clicking save, that will configure my step. So now your dataset comes here, it cleans your data, and then you have your clean dataset over here. What I'm going to do is I'm going to take it and I'm going to train the data. There are a couple of more steps to do that I need to clean it. I need to do on hot encoding, but just for the simplified demo today, we are not going to touch base on that. So let me select the component which is responsible to train the data. So we have something called, uh, and you guys know it is going to be a binary classification. What sort of algorithms will be quite useful to for this? I'm zooming it out for your reference. So we have decision tree, we have linear regression, we have clustering, we have classification. So we know this is a classification problem. So we have to choose the classification algorithm. Which algorithm would be suitable for us to do today? It can be neural network, it can be one versus one, multi-class. So let's go with maybe very basic logistic regression just to see how it works. You use this component and it pulls up here. What you have to do is you have this algorithm, but you need to train your model. So now we are going to find out where is training a model here. So we have an option, a node called model training. You go here and you click train model. The train model requires you two inputs to pass, which is your untrained model and your dataset. So first we need to connect the dataset over here. I'm just connecting it from here. So, and I'm also going to connect my untrained model, which is my algorithm, to the training model here. So all you have to do is do drag and drop. Once you connect both, what it's going to run is that it needs me to input some values. So I'm going to double click it. And it is asking me what is the label column. Does anyone know what does the label column here mean? Very simple. If you need to make a prediction, you need to give what? A label column. Anyone in the comments who can tell me what is label column is? Okay, label column is something that um, we have to actually do it, and which we are going to predict. So edit column, and you going to input something called income because that is what the income the final prediction is going to be. You save it, and that's all it. So once you train the model, once now we have created a very simple pipeline without coding, and that will help you to create your machine learning models with no coding at all. But how should I run this pipeline? Does anyone know how to do it? Okay, yeah. Yasuo has given the right answer, which is label means the final class that we're going to predict. So once you design your pipeline, you have to do something called configure and submit. Once you click on it, you can you need to put this particular experiment. The okay, I haven't explained what the data set is about, so let me do it first so you'll have some understanding. So here we have income census data, which is, let me try to preview it so that you will understand much better. So right click and you have something called preview data. The dataset has around 32,000 rows and 15 columns. It's about having different columns such as age, work class, and so and so. And whether with all these details, like how many hours they work, whether they are this one, it going to show us whether the person falls under a less than 50K dollar income or more than that. And our income is what we're going to predict. So if we give all these details, we're going to predict whether the income is going to be less than 50K or more than that. So again, I'm going to click configure and predict. Experiment is something that you can put into one thing. So I'm going to use my existing experiment name called ML. You can give your own job name. So Azure Demo Live 1, which is something I'm giving here. Description tags you can safely ignore, and you click review and submit. Okay, it runtime settings. It asks me to select where should I run this pipeline. Correct? We need to do it. So we need to go into click. We have already created a compute instance called this one, and I need to select this. So unfortunately, right now this instance is not running. So let's go ahead and let's go and turn it on. Okay. So I'm going to compute. Okay, sorry. Let me save this pipeline so that I can come back and create it. Go to compute, and once this is stopped, we are going to turn it back again. So I have set up an ideal shutdown that once there is no activity in the instance, it automatically shuts it down. So that is the reason it is shutting down. You can take away that constraint to make sure that it does not happen. So once the stopping is done, you have to again click start, which will start it, which might take a little bit of time. So what we are going to do meanwhile is that it's not moe moe actually, so it works. So compute instances work in that way that instances run, you can shut it down, you can actually run it, open it whenever you want. And sure, it does not actually happen today's demo. So cool. So we go to this and we'll see explore the other stuff before we go into this. Until we turn on the compute instance, which might take 3-4 minutes, I'm going to introduce to you to something called an automated machine learning. So an automated machine learning, we now saw a designer that you define that this is my data set, this is how I need to pre-process it, and this is how I need to connect my training model. And there are multiple models here. There are you can bring your own model as well. But can you is it possible to automate all this stuff without without coding? Any answers that can you automate your whole machine learning workflows? That once you give your data set, your some service should be able to take the data set, clean it by itself to know which columns to clean, and also it can also train around 50 to 60 models or more than that and select which model was the best and also hyperparam and tune it and give you the best model, which is basically if you go back to the presentation that we were seeing earlier that we had a lot of workflows, right? If that whole workflows can be automated, this is what the service actually does. So let me take a little bit of break. So yeah, let it stop. Doesn't matter. Okay. So we will now see what is an automated machine learning. So first you're going to create a job and you're going to give a job name. Very simple. I'm going to give AutoML live 2 and I'm going to put that into ML experiment, whatsoever, however you want to do it. Now I'm going to select the same thing, which is I'm going to select the credit data set and I'm going to train it. So I've already uploaded the data set is available. I'm clicking credit. Okay, it doesn't allow, and I need to select which type of problem is that. So credit is to classify whether your income is less than $50K or more than that, correct? So how do you ensure what type of problem is it? Then it falls under something called classification. Yeah, sort of a way you can use infrastructure as a service, but that is where you define what should be executed after. This is more like you automate the pipeline, right? But can you automate the process of which columns to select in a data set and what sort of pre-processing steps should we apply on it on the fly? That if I give you any data set, it should work upon. So it all this is done by your automated machine learning that give your data set and it will give you the best machine learning model available with the best accuracy. Sounds good, right? You don't have to do anything. So once you click on the type of data set, type of problem, which is your classification and your data set, click next. And what is our label or your class? It's about okay, this credit is slightly different. This credit is okay. We'll take up a new data set called credit. This credit is about given all the details about what the person does and how many loan EMIs he has paid, you're going to predict whether the person will pay the next payment, EMI payment or not. So that's a machine learning problem. So the final class is about predicting whether the person will pay the next bill or not, next EMI or not. I'm selecting the target column and validation. You can go for K4 validation. I usually go for 5. Oh, click. No way it's possible for all data sets. Yeah, in a way you're correct. Let me say, oh, sorry, I logged into a wrong instance. Sorry, I'll get back to. This one. You can actually train on all classification models, your regression types, and it now is in the preview of NLP as well, which means you can deal with text data as well. Okay, I'll re-log in if that's the case. Okay, cool. Let's get back again. Cool. The computer stopped. Let's kick it back again. Is it okay? And let's see what all data set, what type of data sets it can actually handle. Quickly, I'm going to do this. So it can support classification dataset, it can support regression type, time series, and also it can do NLP and computer vision. So I have tried classification, regression, and NLP. It works pretty decently. So sort of it can do most of your workflows. Is it a good idea to automate machine learning? By using this, people will become lazy and they forget coding. Okay, good questions. So this is something that an automated machine learning gives you the best model. But once you give, I'm not sure. Okay. So it's not about forgetting or becoming lazy. It's about increasing your productivity. Using these models might give you a couple of models, but including your domain experience that uh, for example, a finance problem that you're dealing with, you have to put in your domain expertise to do some processes, which makes it much more better. This is very good for a quick and some very decent accuracy, but if you want to do a research, that's where you have to put your own coding as well. Don't worry, I'm still going to get into coding right after this. Okay. So we are doing with classification, click credit, target column, and guys, again, the computer's back. So good that good that we are having it back, and it won't shut down for next 1 hour. So no worries. So whether can you train it in your instance? Can train it here. It has in our serverless option that it can train and shut down. Once I click next, I can submit this job. Submitting this job will evaluate nearly with it will do the pre-processing, it will do evaluate with nearly 100 plus or 50 plus models, and it will hyperparameter tune the model and will give you the results. This will take 2 to 3 hours. To ensure that we don't have that much of time in demos, I'm already have run a couple of answers. So let's see how it looks like once it gets completed. So it complete today morning I created this demo, and it will give you all the relevant this one. The reason why the model accuracy is bad is that maybe because of the sampling and so and so. But this is where the people who ask the question, whether can it give the best model? No, it might not always. So this is where you have to put your expertise to make it much more better. This is the best model according to the data and it trained, and it show the metrics along with it. AUC is this one, and so on. So you don't need to care about accuracy here. It's F1 score and so on. So, but anyway, our deal is to not to learn machine learning here. It's about how to do machine learning. So let's ignore that part, and this is how it looks like. Okay. So once that is done, you have created your automated machine learning, which means you can automate your whole entire stuff without having to do any coding. But our one of the objectives of today's session is to do it end to end. Okay. So that is by creating the environment, creating the training script, running it as well. So let's do it today. And most of them is available as a code. All you can do is just sit back and enjoy the coding session. I will give you the coding notebooks that you can try it out later. So first thing first, you need to have your instance to run your Jupyter notebook. So I'm going to instance, and it itself will create me something called a Jupyter instance. Once you click on Jupyter over here, once you do it, today I'm created a folder called demo day. It's as usual as your Jupyter notebook, but just imagine that is running in your cloud. This is my end-to-end coding. It has everything that you have to do, right from importing the data, training environment, and everything. So, any questions before we go into the coding session? We have saw about designer, we have saw about automated machine learning. We also learned about the basic concepts of what an Azure Machine Learning Studio has, and so and so. Any questions before we go into this coding aspect? So I'll run through these code quite quickly. I don't want to take much of a time. So first things first, you have to create an authentication about which machine learning workflow that you're using. It will do the authentication by itself because you're running it directly inside the compute. But if you're running it uh, in your social handles, then it might you have to do this authentication process by yourself. That is nothing but it will give you a sign up window and you have to click sign up. Second thing is I need to connect my workspace. My workspace is nothing but the whole ML Studio is my workspace name, right? What is written over here. That is getting connected. So this notebook is now connected to the workspace. Now the third thing is I need to connect my data set to this particular uh, workspace. So this particular data set is already available publicly. So I can just show you that. So we have seen about uploading your local files and everything. This is a publicly available data set. I'm just importing it right away into my workspace and I'm giving the name of what is the data set name and everything. Let me run this as well. Once it is done, it will create a dataset name under this particular dataset version and tags along with it. Now I need to import or create this dataset that I can use it within this particular notebook or the workspace. So I'm creating the dataset and I'm using ML clients data.create or update using this particular object of data. With it, the dataset is now registered to the workspace with the dataset name. So let's go and check whether it is done. So we already have something called uh, bootcamp credit data and it is now updated. So the reason why it is not being updated right now is because I've given the same version, but let me give another new version and see how it works. See, now it's updated that I am given 1.0.1 and it's created at 12 p.m., which is right now. So now this data set is registered within your workspace, which you can use it for your machine learning purposes. The second thing is called to create an environment. An environment is nothing but your environment is nothing but a set of dependencies that you have to install to make sure that you can train or your deploy model. So for us now, training is a thing, and I'm going to install a couple of machine learning packages or your Python libraries, which includes this and this. And I'm writing it down to a file name called dependencies slash conda.yaml file. This is the YAML file. If you're not familiar with what is YAML file and so on, so just imagine this is a file, nothing but very similar to requirements.txt. So once I run it, if I go to my, okay, first I need to create this environment and then I'm going to run this. If you go here and it has created a folder called dependencies and it has called something called conda.yaml, which has exactly the content which we have written it over here. Now we are going to create an environment with these dependencies. So we are going to use a function called environment with the name custom name and all this, and we are going to point it to the file listen. So once that is done, we are going to point it to the conda file called conda.yaml over here. Let me run this. So now we have created an environment for me to run it. So as imagine our first step was like to create data and to create environment and you connect both and you so that your training script can take the data and run on that environment. So now we need to create your training script. So the training script has something called over here. And imagine we skipped a little bit of a topic called environment run context, which is nothing but over here. You can log any values that you want during this particular run. As I said, every time you execute this experiment thing, it's called a job and it's called a run. So it has your basic stuff that create, test, train, and then you create your model, predict, and you finish it off. This is your training script. This does not initiate training. When does it initiate training? When you have to create your whole command job of saying that my data is this, your credit path, and some inputs that you have to pass. And then you are going to run the command called main.py. This is your main.py. And I'm going to pass some parameters to it. And what is the environment that we have created here? Bootcamp underscore credit env at Playstyle. So if you have any questions that you have to ask, please do ask in English. I do not understand Telugu. Or if this is the place for you to do chats, I said that this is not the right place to do chats. You can do it externally over WhatsApp. This is where you can ask right questions over here. So coming back to the session, um, you prepare your data, you train your model, you save and register your model. Once you run this particular flow, you will be able to see your models inside here, which you can deploy. We'll come back to it a little later. Then when you actually do this run command is where it takes your data, it takes your environment, and it takes your experiment name and it runs it. Right now, if we run it, it will take a couple of time to run it. So I'm going to skip this particular thing and show you the outputs directly. So once you do this particular, run this both sections, it's going to show you something called the experiment, the name of it, and command. This is the name of the job. Let's go and check if the job is actually created. So bootcamp experiment credit, and it has completed once you run it. So it has the following metrics of these and these. It has a training accuracy of 0.8345 and so on. So it has 0.81 F1 score, which is quite good. So this is how you can actually run your machine learning model. Once you do it, what you can actually do is that you have your now comes the most important part where most of them has created machine learning models or run machine learning models or trained it in your local system. Now we know how to train it in cloud, which means you can leverage the instances which is available there. But how do you ensure that you can take this particular model and you can make it available for public to predict or send requests to get the prediction? That is where the deployment comes into picture. Again, I said when it comes to deployment, it takes you two things again. One is your environment, where you have to create your deployment environment, your training script, and so on so. So once you do it, you need to create something called an online endpoint. This is fairly simple. Endpoint also does cost you, so I'm just going to make it this way. We are going to use something called a managed online endpoint. A managed online endpoint is that it itself will take care of the instance which is going to run. Okay. And you don't have to do much of it. So once you do it, it will create your instance and it will create the whole, once you run all this, you have created an endpoint and with the provisioning state as succeeded, which means it is done. Next is you have to create, you need to put your machine learning model inside that so that it can, whenever there is a data coming, it will predict it. So first I'm going to pick the latest model, ml.clients.models or list in the registered model name. So once you've done it, it goes over here, it has your name and it will import it. And all you have to do now is to create your deployment. So name and create an endpoint, create a model, which instance are you going to deploy it, and the count. Once you do it, it itself will deploy your whole machine learning model. So for now, till now, people were assuming that deploying machine learning models is a tough task, right? You take it, it's very difficult to take a model and publish it so that everyone can access. But all you have to do is run a couple of code, and it's fairly simple. And if you're even not familiar with it, what you can do is once your model is there, go and click deploy, fill all the details and click deploy. Your machine learning model is deployed. It's as simple as that. But again, reminding you that these incur costs, so be ensure that it's not billing you or you don't want to incur any extra cost. Click deploy. We can run output and see whether we are getting an input, which we got it. We also have a Kubernetes deployment. Same as that, you're going to create pipeline step and going to run it. This is something that I would like you to go, guys, and experiment it out, which is fairly simple. Where you can go and find it, you can find it in my GitHub profile, which you will find it in my link tree. So it's called Azure Bootcamp, and you will have all the code samples available here. So once that is done, we are good to go and we have done the most of it. So just to recap what we have done so far is that we have our home, the studio, which has everything. You can create GenAI models as well. Go try it out. We have explored automated machine learning where you can import your data set. It does the whole pre-processing and it explains you why it does it and it gives you the best model with accuracy. You can deploy it right away. Or you can create pipelines where you can create pipelines and deploy it and see what's the accuracy of it. And you know what is pipelines, and you know what is environment, you know what is models, and we have created an endpoint. So whatever the endpoint that we created there, it is dedicated that I can now see how it really works. So once that is done, you have actually done the end-to-end part of it. Now to ensure that I'm not incurring much of the cost, I'm going to shut down my compute for the move. So now let's head back to our presentation. Let's do a final check, and that is it for today. So just wait till we head back to our presentation. No, Bhairava, we haven't still completed it. We have a final little bit of touch to finish. Let me go here. Okay, now we know that how we can actually train. Let's quickly revise what we have seen here. So now we know what is a workspace, experiment, run context. We trained it using a designer. We use automated machine learning, and we also did the coding part, and we did it as well. So these were the steps we followed. Create the directories, create your ML script, create environment, train the model, and once the model is done, you have your metrics. Same goes for deployment. You create your scoring script, you create your inference deployment configuration, which is like we were telling what instance and everything. We did local compute. We did something called AML compute, which is your managed endpoint. We also have a Kubernetes service. The code is available. You can try it out if you want to. And that is it for today. So I think that covers a very basic understanding about how to find your data source, import it to your Azure Machine Learning, uh, and also can you again add the presentation back to the screen? Sorry, yeah. So we now saw how to import your data source. We know how to create your training environment. We selected a machine learning model. We created a training script. We trained the model. We didn't do hyperparameter tuning, which you can possibly do it very well because now it's all available. Finalize the model. We created a deployment environment and we created an inference script and we performed the prediction as well. So that is all about machine learning. So today we have seen something like all about introduction to machine learning, training models, and we deployed it. So you can go ahead and join our community for further more sessions like this. And this is my link tree, which has all necessary social handles of mine. And if you need one-on-one mentorship, I also provide that. And it has my GitHub profile where you can find the source code of this particular session. So that's all. With all being said, thank you for today's session, and I request Lakshit to hop on for the stage. You're muted, Lakshit.
I'm sorry. So thank you, sir, for giving the detailed demo. And everyone, I hope you is the. So there is one question. If you could address this, sir.
Yep. Okay, I think one question is that is students can get free account to perform these instances for free. Thank you for this question. You can actually avail Azure free account with $200 once you sign up with your credit card as well with your student pass as well. So if that means it gives you a liberty to go and try it out. So yeah, you can still do it. Yes, but be mindful of the cost which it occurs. Though everything is like it's free, just keep an eye on the cost so that you don't incur any further future costs.
Absolutely. And just to give you a gist, so we at Azure Developer Community, we are coming up with some a couple of initiatives. So I'll quickly give you a brief wherein you can always try out for these Azure credits, right? So I have written seven. So in this blog, I have written 7 ways as a student by which you can. So there is MLSA program, Microsoft Learn Student program. You can get $150 credits for free as an MLSA program per month, and there are some other programs which you can always enroll and try out the Azure credits. And at Azure Developer Community, we are doing a series of 100 days of cloud. We are doing 100 days of cloud. If someone wants to learn cloud for next 100 days, feel free to join. We have designed the content. We have designed the entire schedule here. It is in the GitHub link. So I have shared with you 3 links. So there is one ongoing initiative of Microsoft, that is AI Odyssey series. So this is more about, so you have right now explored about the machine learning models and how the ML Studio works through Azure portal, right, from Vivek Raja sir. Now when if you want to explore more about Azure machine learning and NLP services documentation, OpenAI, right, try to join the challenge. There are some couple of challenges that has been introduced by Microsoft. It is a Microsoft Learn student guide. You can always go through these, and the best part is for top 500, on top 500 completions, we have Microsoft Fanny Bag. So if you will complete, so we'll get a certificate. So there are a couple of perks of completing this challenge. So you will definitely get a certificate if you complete both the levels. Also, again, this is from the certificate from Microsoft. Second is you get Microsoft Azure swags like merchandise, like so fanny bags, t-shirts, or something likely. So if you want to explore, if you want to get some cool swags from Microsoft, this is another way to get it. Third would be about the so certifications and vouchers. There are so that if you can always get a 50% discount as a student on every student certification that you want to any easy any 9 grade certification that you want to acquire. You can get 50% concession there. Also, if you want to apply for an MLSA, there you can get something around 70% of concession in certification vouchers, right? So you can always explore those. Not likely 100% Valasla Rakesh. 100% free vouchers are available in some kind of initiatives. We will definitely let you know once we are coming up. Like Microsoft Ignite is there, and there are some couple of other initiatives which gives you 100% free credits, or maybe vouchers or certification vouchers. But not at present. We are giving away the 100% credits for free, certification vouchers for free. But yeah, there are some. We are working upon it, so we have some plan. The plan is in the pipeline. So if we will follow up this 100 days of cloud series for next maybe 50-60 days, right? For next 50-60 days, if you will continue the journey with us with 100 days of cloud series with Microsoft Azure, we will try getting you the 100% certification voucher for free, right? So this is what we are working on. And always we have our Vivek Raja sir has already given you the mentorship, the or the Azure Developer Community social. So feel free to follow us through those socials. We are coming up with lots of initiatives. We are coming up with solo offline initiatives, offline boot camps, online boot camps. So looking forward to host you again. And again, it's my pleasure to host you, sir, for this. And thank you for taking out your time on on a weekday for these community people. It was really nice hosting you, and thank you for your time, sir.
Thank you so much. That was lovely.
Yeah, thank you everyone for joining in. See you next time. Have a nice day. Thank you everyone.